Hi, everyone. I think you can hear me very well. So I think my own presentation is going to be a little bit different from what everyone else has presented. I'm just going to talk more about my facilities and what led us to go into this project, more like mobility project. So, like I said, my name is Udo Okoro, and I'm working with Suraj Prasad, and I have multiple projects I'm working on, but I'm just going to talk about one of them. Okay. So this is in our lab, we have a static autoclave, which we're using to do, I use it for different experiments. So I have a static autoclave made of a Hasselblad C276, can go up to maximum pressure of 70 megapascal, maximum temperature 350. So currently I'm doing high temperature, high pressure experiment, which is exposing steam generator alloys, different steam generator alloys, alloy 600, which is used by boiling water reactors, 690 mainly European reactors, PWR, and alloy 800, which most can from European plants also tend to use. So we're exposing those alloys. So in a steam generator, there tends to be what they call heat transfer curving, which occurs between the steam generator tube support plate and the steam generator tube. So at that little crevice there tends to be a large deposit of impurities at that point. So in our lab, we're kind of studying the behavior of all those impurities. So someone else is working on chloride, another person is lead caustic, someone else, me, I'm working on acid sulfate. So all those impurities in our lab, we tend to study them individually to look at um, how are they affecting those alloys. So at that point, steam generator alloys tend to form passive films. So when there's a breakdown of passive films, probably by pitting or whatever, fretting or whatever, that tends to do when those passive films are broken down, heat tends to occur. From heating, it tends to get, when there's stress in the environment, it tends to have what we call a stress corrosion cracking. So currently,
Still not working? Oh, yeah.
so this autoclave will tend to have, this Teflon tree, which I constructed to, expose my samples to the autoclave. So you have a Teflon tree, you have a U bend, you have a C ring. So this is a U bend, this is a C ring. So both of them are stressed at different strain rate, at different strain. So U bend tends to give you about 9% plastic strain, while C ring tends to give you about 2%. Well, so we're also looking at how does this strain rate, how does this strain affect the behavior of these alloys in this environment? So they go to up to 280 degrees C. So pH of the solution at room temperature gives you about 1.64, 1.61. So but at 280, because of bisulfate dissociation, it tends to go about up to 4.62 and thereabout. So more like I said, different tests we can do with this, immersion test, when you're trying to look at your weight loss, probably SCC as well. You can also do immersion test, electrochemical studies as well, strain rate, slow strain rate, DCP, direct current potential drop testing, and, different bunch of tests you can do with it. So for my PhD, I'm looking more on the immersion test and electrochemical studies. So currently in our lab, we don't have the ability to do this electrochemical studies, because we have the facilities, but we are not yet to, put them in place. And, putting it in place is going to take us like another 1 year, which, I don't have left in my PhD. So we found out, okay, where is the next available lab whereby you can go, to carry out this test, cut down on my, experimental time, trying to figure this guy up. So we okay, this is kind of some of the results, SCC results I obtained. The cracks obtained from this study are not actually the type of cracks we're looking at. So this is more like a blunt, wide open crack. We're looking at a very thin crack into the material. So which made us to, leave this test a little bit for now, which, I'm going to come back to as well. So my mobility at University of Toronto. So I got to U of T in March, at Roger Newman's lab, and this is some of the electrochemical studies here. So this is how you set up, the autoclave system. You have your gas in, gas out. You have your working electrode, your reference electrode, and your counter electrode. So we're doing more like whole bunch of electrochemical studies on it. So this is more like the computer system where you have to pick up your right, more like your controller to control your autoclave. So you see here, I'm getting to my set point at 280, pressure at 81 bar, and what this controls two autoclave. The capacity of this is about 0.5 liter, like 500 ml. Why this is about 2 liters. So this is a big one which no one uses currently, and this is the one I'm using. So this is more like chemical cleaning station whereby we tend to clean our electrodes after each experiment, trying to like do chemical cleaning of all our electrodes. Um, so this is Anatoly. I don't know, some of you might know him. So he's working with Roger Newman. So some of the results obtained, trying to compare what currently have in the literature. So this is my current result. You're looking at about 800 at 0.55 sulfate. Looking at different runs, 2 hours and 24 hours. So I'm trying to compare with Suraj's work. So this was Suraj's PhD thesis. Looking at about 800 in similar conditions as well. So this was the work done by Kevin and Gerard Smith at CNL. Looking at the same concentration of 280 degrees, 4 point, their pH 280 degrees, theirs was at 4.2. So that pH was about 4.3, and my pH is about 4.0. I'm using 4.0 pH. So looking at the effect of pH in all these different studies, that's part of what I'm doing as well as UFT. So challenges are going forward. So one of the issues I had when I got to what I was supposed to start in January. So one of the challenges was trying to get accommodation at downtown Toronto, which is crazy expensive. So looking at the budget we had, and trying to fit it in, looking at a 3 months to 6 months program. If I started in January, I don't think I would have still been in the program up to then because accommodation students were still around then. The accommodation was crazy that period. So we had to find a way to delay it towards March so that when students leave by April, I can get into the students hostel, and that helps us to cut down on costs in terms of accommodation. So that's one of the challenges I face. Then going forward, I'm looking at doing more of SEC tests, ECS tests, trying to vary the pH. So they're trying to vary from pH 4.0 to pH 4.8 to look at effect of pH on those environments. Also looking at probably if I still have more time, looking at the chemical studies on some of the U beds and breast samples as well. So that is all I had. And